Okay, I want to briefly talk about using Newton's method to do the problem. I'm using a product called Sage. It's open source software. You can easily download it and put it on your machine, or you can even get the web-based application. It's based on Python. So let me go to my terminal, and I have Sage running. And what I want to do is, let me pull into view, and I want to, talk about how to do it. First thing to do, I'm going to reset. That clears the memory out. I'm going to define a variable, x, and x is a variable. I'm going to define a function, f of x, and f of x is going to be, you know what, I'll be in line with this over here, all right? So I'm going to do that. It's going to be 2 to the x, let's see, minus x squared. All right, so what I want to do now is put down Newton's method. And I'm going to define a new function, n of x. And n of x, whoops, is going to be x minus the function divided by the derivative. And that's what n's going to do. Now, of course, we're going to work with that to keep getting a new x each time. All right? I got to give it a seed value, though. And someone said, I wonder what a good seed value would be. Well, it's nice to have a graph over here. And if you look at it, I'm going to say, looking at the graph, I'm going to say it's somewhere around -1. Now, granted, I know it's not -1. I'm looking at it. It's really about minus 0.7. But I'm still going to say -1. So I'm going to say x equals -1. I'm going to use a decimal number because I want decimal answers, by the way. And then what I'm going to do, I'm going to get a new x. And I want to show you that when I get a new x, I'm going to assign it to n of x, and I want to display the x. You notice I'm using a .n notation now. And the reason for that, I am forcing the machine now to give me a decimal number. All right, so what it's going to do? I'm going to take this function n of x, what Newton's method, it's going to compute the number, and it's going to assign it to x. This is going to print it out as well, by the way. And I get this number, which is closer to the solution than -1 was. I want to do it again, though. I'm going to use the up arrow to get the command back. The same command. But now the x is different. It's no longer -1. Now it's minus 0.7869, so forth and so on. It gives me a new guess. Now, of course, I hope you realize these guesses, I'm looking at them, they do differ. Let me keep going. And let me pull this up now. I realize I'm off screen. It definitely changed. I can do it again. That definitely changed, by the way. I'm looking at the end digits to know it changed, by the way. Now, right now, it appears not to have changed. If I hit it again, and I can do this forever, by the way, it's not going to change. So this is the best approximation over here. And that's what I'm saying. This is an approximate method. Could I do that without a calculator? I really don't think I could. Okay, maybe some people could, but I'll be honest with you, the computation would be brutal. Thank you.